Welcome to Ask and Learn.
So in math applications, we often use exponential functions, trigonometric functions. So for that reason, it's helpful for us to be able to essentially take the derivative of those. When we're in calculus, the derivative is such a crucial part of understanding rates of change and all those things that we want to be able to use logarithms, exponents, trigonometric functions, and be able to take their derivatives. So one way in which we do this is if we have a complicated function such as this one right here, where we have an exponential function, but the variable is in both the base and the exponent. So one way that we solve this is taking the natural log of both sides. When we do that, this cosine x is now a power, so it can move out in front and multiply. Then the natural log of y. Now we can perform implicit differentiation. So what we'll have is the dx of the natural log of y is going to be 1 over y times y prime. And then cosine of x times natural log of x, the derivative of that will be cosine of x times 1 over x plus natural log of x times a negative sine x. So when we combine these right here, we'll get the cosine of x over x. So let's be cosine x over x. And then we can get rid of all this. And then what we'll have is the negative sine x times the natural log of x. So this will be a negative natural log of x times sine x. And then lastly, we want to multiply by y on both sides. So out here will be y, but we know that y is x to the cosine x. So thus we have our final answer like this, and we can even move the sine x depending on where we want to write it, but it ultimately means the same thing. So this right here will be our final answer using implicit differentiation, derivatives of logarithms, so on and so forth.